So the prerequisite for understanding security, specifically firewalls or any advanced technologies that you are learning, the prerequisites is always routing and switching. So ensure that you guys know routing switching at least till intermediate level. So I would request, if not, then things will be a little difficult for you to grasp. So ensure that I expect you all know what is routing switching, how protocols operate in the theoretical sense, and you have done some configurations and labs in your previous days. Starting with the concept, I mean, we all joined for ASA right now. We're starting with ASA, which is the recommended way of learning firewalls. If you want to learn any next-gen firewalls, so I recommend you to start with ASA first. Learn the CLI approach of how ASA is deployed and what are the Cisco way of implementing firewall solutions for your enterprises. And then once you are okay with, if you are actually capable of deploying the solutions offered by ASA, it becomes quite easy to understand the other next gen firewalls like Checkpoint or Palo Alto or Fortinet. Okay, things becomes quite smooth, and you can understand the differences. I mean, why they are called as next gen firewall. Okay, so Cisco ASA is literally, it is a product which is decade old, and it is still in sales with Cisco for enterprise customers, but not with generic ASA. It is sold with firepower services. So if you look to cisco.com website, I mean, you can get the information from there as well. So firepower is basically the Cisco's next gen firewall with IPS features into it. That is called as FTD, Cisco FTD, right? So it also has ASA capability, plus it has also the IPS capability of doing intrusion prevention and intrusion detection features of your network. So before we jump to FTD and firepower services and understanding how that next gen firewall operates, we are here to learn ASA and understand the different topics of ASAs. So first thing first, I normally don't use presentations or PPTs or slides because it makes our concept a little boring, what I feel from my experience of long years. So it will be always a discussion session, and also we are concentrating on the topics from basic to advanced. Okay, so hear me out, and if you have any doubts, I would recommend you to keep your doubts in your notepad before the end of the class. 99% time what happens is whatever doubts you have, that gets solved within that session duration. Okay, but still further, if you have any doubts, you can ask me. All right, so going with this concept, so first we'll talk about the ASA firewall overview. So if you know that, if I can ask you a question, I mean, what is a firewall? I think all of you can answer me. I want you to answer me that. What do you mean by a firewall? So basically, it's a packet filtering device, right? Yeah. It's a packet filtering device. Generally, firewall comes in layer 3. It works in layer 3. I should say like that. It works in layer 3 of your OSI. So the idea is it works at network layer and it deals with IP addresses and IP packets. And basically, it's a packet filtering device which inspects the traffic flow and takes filtering decision, right, according to the security policies that you configure, security policies or rules. Right, so basically, you have to configure security policies in order to allow some traffics to span across a firewall network. Firewall are always called as, they are always referred as perimeter device. What do you mean by that? It is nothing but your edge device of your enterprise. So if you think about an edge device, generally you can think like your edge device will be a router. So you have a concept like you have got core layer, then you place your distribution devices, you place your access devices, right? That's your 3-tier architecture. In today's world, you can go with other architecture like a collapsed core. You can have collapsed core architecture, and we can have collapsed core with a single environment. I mean, you use a highly capability switch that connects your WAN and that connects your LAN with abandoned ports, right? So it's a single or 1-tier topology that you can think about. right? So it connects your LAN as well as it connects your WAN infrastructure. Also, we have got two-tier logic, so which goes with uh, a collapsed core and access. So I can say collapsed core and access. And nowadays in data center world, this is becoming very famous. That is spine and leaf, right? So the idea is, we have major spine switches and major leaf switches. They're connected in redundant fashion, right? And between the spines, they don't have any sort of interconnectivity. So, and all the links that we have in spine to leaf, they are basically your layer 3 links, right? Whereas in core, distribution and access layer, if you go with three-tier architecture, I mean, you'll have a layer 3 between the core and the distribution, and access to distribution, it is all your layer 2 links. So you think about VLANs, you think about trunking, STP, Cisco way of VTP, all they are implemented between the distribution and the access blocks. And in the core, you normally run with IP routing. So it depends on your customer environment. I mean, whether you are going with three-tier or collapsed core, or with one-tier or two-tier, or with spine leaf, I mean, you can deploy your firewall solutions at any of this enterprise platform or with any enterprise architecture. Generally, your firewalls are placed at the edge of your network, right? So basically, it is after the core, right? After the core. And also, you can place your firewall in layer 2 mode. So generally, if you place the firewall in the edge, it is called as a layer 3 deployment. And if you place the firewall at layer 2 mode, the Cisco way, it is called as transparent firewall. I will teach you that as well. What's the meaning of transparent firewall and how it is deployed and how it will work. So if you deploy the firewall, within access to distribution block right here, if any firewall is deployed here in layer 2, that can work with VLANs and work with MAC addresses, filter based on MAC traffic or VLAN policies. So that basically, in layer 2 transparent deployment mode. So first we would actually begin our discussion with, layer 3 deployment, basically placing the firewall on the edge, okay, edge of your network. So generally what you do is you can place your firewalls, after the router. So if you have a company, if you have an edge router sitting here, from the edge router, you can connect your firewall equipment as a hardware. And from the firewall, you can connect your, directly you can connect your ISP. That is also one solution, right? Another solution is, your router is facing your ISP. Okay, and beyond the router, inline you connect your firewall. So here, the LAN, so you have a LAN switches over here. From there, you connect your all the enterprise devices. So LAN lives here. Now, what happens is beyond the firewall, you'll be connecting your switch, and from there you connect your LAN. So depends on majorly one thing. Okay, so you see here the first design that I'm talking about. I've placed the firewall directly connected with the ISP. So let us say this is your LAN, the interface of the firewall going towards your LAN, and the interface of the firewall going towards your WAN or ISP, right? So generally you can do that if you don't think of running BGP, because you don't want, though the firewall supports BGP, but you don't want your firewall to run BGP because BGP is a processor intensive protocol, as we all know. So because of which, you can place the firewall beyond the router. And if you think of running BGP, I mean, then you can place the router that runs BGP deployments with the ISP. So basically, the placement of firewall on the edge depends on majorly one thing, which is implementation of BGP as a routing protocol. All right. So regarding ASA, right? When you talk about ASA, stands for Adaptive Security Appliance. It is a decade-old generation of Cisco firewall. Normally, I'll share you a link in the group. You will see that ASA product line normally starts with 5500 series. We have 5504, 5505, 5510, 5520, 5540, 5580. So I will share you one data sheet, right? So on your free time, you can go with all the product lines of it. But the whole idea is, the different models that you take of the ASA firewall, the only thing it differs is the throughput that these firewalls are going to offer in terms of bandwidth consumption, the amount of bandwidth based traffic that the firewall can handle, inbound and outbound, and also the processors then also the number of interfaces that the firewall has in order to connect your devices. So the way you implement on a 5500 and 5505 and a 5580, the way you implement the configuration and the way you manage your policies, I mean, they are going to be the same. So your configuration syntax, your configuration methods, your engineering does not change between the model numbers. What changes is basically the hardware specification, not the logical implementation concepts. So talking about ASA, so basically ASA actually came up from a concept. So you know that before ASA, so Cisco was having its own firewall called as PIX, right? A packet internet exchange, and PIX was generally doing all the firewalling capabilities, right? Filtering traffic in and out, monitoring the traffic flow, taking decisions based on the security policies, what you write. So basically, it was you can say the first gen firewall, which was converted to second gen. And the second gen firewall, what happened is, it became stateful, right? So stateful, basically, you can say first gen firewall are basically your packet filter firewall, which inspects traffic only based on layer 3 and layer 4, properties like IP address and port numbers. But in case of stateful, what happens is it can maintain one very important table called as a connection table. So connection table normally keeps your session information. So it keeps your session info, right? So which particular user has traveled through the firewall to which destination, what was the source IP of the packet, what was the destination IP of the packet, what was the port numbers, right, the traffic was having. So all those information, it is maintained in a specific table called as a connection table, also called as a user session information. So that was there in the second gen firewall in the stateful nature. And nowadays what we have is, after second gen, we call the firewalls as next gen, right? So next gen firewall has got inbuilt, IPS capability, inbuilt malware, or you can say anti-malware detection capabilities. You have URL filtering capabilities. You have got inspection, which can happen based on content ID. Inspection can happen based on application ID, user profile. So the things has really changed, right? So I mean, not only that, even device profile. So you can actually inspect a particular traffic going through a firewall, not only based on IP addresses or port numbers, but also with multiple other criterias. For example, I cannot send traffic to internet using, let us say Google Chrome as my application browser, but I can send the traffic towards internet using, let us say, Mozilla as a browser-based application, right? Or even content ID. So you can access, Facebook.com, but you cannot use the chat feature, or you cannot use the messenger feature of Facebook.com, right? Device profile. You can access a corporate network by using your laptop, but you cannot access the corporate network devices using personal appliances like phones or iPads or something like that. So you have got multiple ways in the next gen firewall to actually filter your traffic. You can think of multiple sources of filtering. So keep this in mind that the first gen firewall is packet filtering firewall. It works in layer 3, layer 4. Second gen firewall are becoming stateful, so they can maintain a connection table of the user session information. So basically, in the session information, also called as a connection table, it maintains the user source IP, destination IP, and the port numbers. And in the next gen firewall, for example, Palo Alto, we can think about Checkpoint, we can think about Cisco FTD and whatnot, Fortinet, Dell Sonic, Barracuda firewalls, Redwire, McAfee. There are multiple, right? So all those are classified as next gen. The reason being, they have got advanced way of implementing the solution, along with stateful, along with inspecting layer 3, layer 4 properties. So talking back, I mean, Cisco have developed ASA, but predecessor of ASA was PIX as the firewalling device. But PIX was lacking. I mean, though it was doing the stateful way of packet filtering, but PIX was lacking with one important VPN solution. So it was supporting IPsec VPN. It was having capability of IPsec VPN. It was having capability of L2TP based VPNs. It was having capability of PPTP, right? But what was lacking in PIX firewall was capability of SSL VPN. So normally this SSL VPN became the most important VPN solution for remote access users, right? For example, you be anywhere in the world, I mean, you can use this remote access solution using SSL VPN to connect to your corporate networks. I will discuss these things when the time comes. So at the end of the day, I mean, the PIX was not supporting SSL VPN, or basically remote access solution, because of which, PIX or Cisco actually acquired one company called as Altiga. All right, and Altiga was developing, one product called as VPN Concentrator. So this VPN Concentrator appliance, I mean, it supports all types of VPN capabilities. I mean, it has got SSL VPN, IPsec, you name it. I mean, IPsec, all flavors, like, IKEV1, IKEV2, L2TP, V2, V3, PPTP. I mean, get VPN, talk about, site to site, any sort of deployment scenarios, VPN Concentrator used to support. So now what ASA has done is, I mean, ASA is basically, it's a combo of two things, okay? It's a combo of PIX, plus it's a combo of your VPN Concentrator appliance from Altiga, and they bought together. So now the ASA firewalls supports everything. I mean, it can do the firewalling property, and it can also do all types of VPN property, including that it supports all types of your routing protocol choices that you can deploy, right? Any routing protocol, including static route, static and default route, RIP, EIGRP, OSPF, and also BGP, right? So all those protocol deployments are supported nowadays with your ASA firewalls and also the next gen firewalls. But PIX was lacking capability of BGP, by the way. If you have anytime worked with PIX, if you have worked, I mean, that's saying PIX was not supporting BGP, but ASA introduced BGP into it. All right. So the basic idea is, ASA became a combo of PIX and VPN Concentrator. I mean, it supports all types of VPN, all types of routing solutions, and that's it. I mean, there is the evolvement which came up. Now, when you talk about ASA, by default, I've told you that ASA is generally, it's a layer 3 device by default. So it's a layer 3 router by default. You can think in that way, right? So it's a layer 3 router by default. Okay, and it has got all the routing functionalities, that a normal router can do. I told you that it can support all kinds of routing, like static and all kinds of dynamic routing protocol. The basic difference what comes up between a router and an ASA based firewall is this. Okay, so when you take a router, for example, and when you connect, let us say, two interface of a router, and you take, let us say this is port 1 and port 2, and you have got some users over here, say A, some users over here, say B. Say this is a 10 dot series subnet, so 10.1.10/24. This is, say, 2110/24. I mean, what the router does is, I mean, you place an IP address on the interface from the respective network, and the router keeps a routing table, and it will have the entries as directly connected routes. You have the 10 dot series subnet over here, 20 over here, as directly connected via the respective port 1 and 2. Now, what happens is, if A wants to communicate the trafficking towards B, or vice versa from B to A, when the packet is sourced, let us say, from any thing of 10 dot, let's say, just for fun, and destination is going towards, let us say, 20 dot series. So what happens is, the packet goes towards the router takes decision based on the routing table, based on the destination IP of the packet. So if he has a route regarding 20 dot series network from a routing table point of view, then the packet is routed by following the routing entry. If the router do not have the destination IP in the routing table, so don't have an entry regarding the destination IP matching in the routing table, the packet will be discarded at the ingress interface itself. All right. So the whole idea of routing is, like, if it notes the destination based on its routing table entries, the packets can be routed to and fro. If it does not know, the packets are discarded. That is the generic idea of what is a router. I think all of you know that. But if you take an ASA, right, and you connect, let us say, two interface of your ASA with two devices, again, say we have A over here and B over here, same story. We have got 10 dot subnet, we have got 20 dot series subnet. All right, you place an IP address, let us say 10.1.1.10 on the interface of your ASA. You place here port 1, port 2, by the way. You place here 20.1.1.10/24 on this interface. It also maintains a routing table like a router. So the ASA says, oh, I have a connected routes. I have got 10 series via, as directly connected via port number 1. I got 20 dot series subnet connected via port number 2. It maintains a routing entry like a routing table. But what happens is, by default, your ASA does not allow traffic through the firewall. So I'll talk to you regarding this. Is a very important concept called as a through traffic versus to traffic. We will discuss this in a moment. Hold on for that. But by default, what happens is, though you have the routing entry here for 10 and 20, but can 10 dot series communicate with 20 dot series? The answer is no, right? Though the routing entry is there. Or can 20 talk to 10? No, it cannot talk. So what it needs a very important concept, that though I have a routing table entry regarding the networks, but can they communicate through me? The answer is no. They cannot talk to me regarding this routing stuff. By default, is not allowed. No packets can travel from A to B or B to A right now. So how do you make things happen then? Right? That is the default nature of firewall. So firewall does not allow anything by default. That's a good property, right? So on ASA, as compared to router, okay, so what we do on the router, let's talk about that first. On the router, let us say you go to an interface say F0/1, you activate the port with a command called as no shut, and then you give an IP address. You say IP add, you give 10.1.1.10, and then you give the mask, right, which is say 255.0. That's it, you define, nothing else. So go to the interface, activate the port, give an IP address with the respective mask, and that's it. It builds a routing table. That's what the port of a router needs, right? But when you talk about ASA, this is router, okay, I should say this is router. So on ASA, what we need is a different approach. You go to the interface, even the interface conventions are same. Generally, on the ASAs, by the way, these ports are your gigabit Ethernet ports. So all the firewall interfaces by default, I mean, they support at least 1 Gbps. All right, so they are all 1 gig interface. So you'll not have F here, you'll have gig ports. Okay, say G0/1. Then you say no shut, activate the port. You give an IP address as per the requirement. Now there are two choices over here. If you are defining a classful IP, okay, if you're defining a classful IP, there is no need to define the mask. Okay, if you are defining classless IP, then mask is required. So what are the classful IPs? Those IPs which has the default CIDR based on the respective classes. So if you want to talk about class A, class B, class C, right, any IP that you are defining with the default CIDR, they are classful. But whereas in case of classless, they have the VLSM based concept, right? So you define the respective IP address with the mask, and then there are two additional components that you must define on the ASA. Along with IP address, along with no shut, there is two additional components, and it is a required component. What are those? We have to define a name to the interface using a command called as nameif, and you should define something called as a security level to the interface, right? So make sure that on ASA you define two additional parameters, which is a required parameter, required component on the ASA, which is not required component for the routers. So nameif, basically it is the name of the interface that you are referring to, and security level. There are two things, okay? As of now, concentrate on this. So now what is the meaning of nameif and security level? Okay, so going further, I mean, you understood that, the router interfaces, they do not need nameif and security level, but ASA would definitely need it under the interface context. All right. Now, what is nameif security level? That's my next level of discussion. So if I take a ASA, generally what you do is you keep two interface, or say three interface, okay, and this is your edge device right now of your company, and this is going to your ISP. So the interface, just imagine that this is port number 1, port number 2, port number 3. So port number 3 is going to a separate, zone. Let's say it is going to a switching network, a switching infrastructure, which connects your company's servers. So you have all the servers placed here, And basically in the context of networking, I mean, you call this as a special zone called as demilitarized zone or DMZ, right? And you normally allow the servers to be placed in DMZ, which is basically the public facing servers. So you want internet people to come and access your servers through internet, and you place your servers on the DMZ zone. So this interface is going to DMZ. This interface number 1 is going towards your internet. This interface number 2, let's say it connects your might be your company's layer 3 switch, or might be your switching infrastructure, and from there it is going to your your LAN corp network, right? So as per deployment scenarios is considered, you normally place this particular interface, you call this as LAN port, but generally you will name this port as inside with AS's context, I'm saying. Okay, inside this port number 3, you will name this port as DMZ. And if you have multiple DMZ, you can place like DMZ1, DMZ2, DMZ3, like that. And normally you will place this interface with a name called as outside. Okay, so outside interfaces are basically the untrusted interfaces or untrusted ports, because it reaches your internet provider. You reach public networks over here, so it is basically the untrusted interface. The most trusted interface, if you compare between inside and DMZ, will be inside, right? Because DMZ resources are generally accessed by public, you allow their access, but you do not allow generally the internet access from internet to LAN or side network, right? So that is the most trusted one. So what you do is, in terms of trust, when the concept comes in terms of trust, it is actually represented with a term called a security level. So the concept of security level is basically with referring to trust. So you have got security level that ranges from 0 to 100 in ASA, where 0 being the least trusted interface, where 100 being the most trusted interface. This is absolutely important in case of ASA to begin with. So what you do is, you go to the ASA firewall, you go to the interface, and you give the respective IP addresses, because all these ports are your layer 3 ports, they are your routed ports. So for example, the interface number 1 that leads to towards your ISP will have a public IP. So say this is 11.1.1.10/24, you assign here. The inside interface will be having your private IP. Say it is 10.11.11.10/24 over here. Even the DMZs will be part of a private IP. So say this interface you gave 172.16.1.10/24 over here, right? So this is basically public, but rest on inside and DMZ you keep the IPs as private. Okay, private. Now the interface, along with your IP address and mask configuration, they would need 2 parameters I've told you. One is the name if. So name if, you configure this port as outside, you give name if as inside, you give name if as DMZ. These are the names of the interface that you are referring to. Okay, and you need to configure the security level as well. So security level by default what happens is this: you put any name to the interface, the security level will be 0 except one name, which is equivalent to this character inside, and it is not case sensitive. The moment you configure an interface with a name called as inside, the security level for that interface becomes 100 automatically. When I show this in practical, it will make really good sense, but try to understand this. That means if I go to port number 2, configure its IP address and mask, configure the name if as inside, and given the name if as inside with this character called as INSIDE, automatically the security level becomes what? 100 here. Whereas if you keep the name as outside or DMZ any other name, by default the security level will be 0 on these ports. Okay, that is the most important thing. Generally, you do not want to keep the DMZs with a security level of 0, because DMZs basically they are not a least trusted zone, right? So what you feel is, what you normally should do is, you should actually keep the outside with security level of 0, because they are the most they're the least trusted, and DMZ falls between inside and outside. So normally you keep a middle value, say 75 or 50, whatever, like that. So ensure that the DMZ interfaces, they have a security level which is higher, higher than outside, okay, but it should be lower than inside. All right, because the most trusted one is the inside networks. They're the highly trusted. That is the reason they will have the highest security level. All right, so how do you configure that? I will show this to you. You go to the interface, say whatever interface number F0, say G0/1. You give an IP address with the IP address and mask. Then you give no shut to activate the port. Then you configure a statement called as nameif. You give the name of the interface, and then you give the security level, if required, to the interface. This is my recommended way of doing it. Now, once I configured these parameters on the respective interfaces, the ASA will build up what? A routing table, which will have now 3 directly connected routes. So it will have a 10 dot subnet, it will have a 11 dot subnet, it will have a 172 subnet. In the routing table, you will not find, you will also find the port number, but generally you will represent this routing table entry with the nameif statement. So the 10 is going to your, inside. So you'll find in the routing table, the routes are represented with the nameif keyword. Likewise, 11 is going to outside. You will find the keyword as outside. Likewise, for DMZ1, if you are given the name like that, it will be DMZ1. Now the ASA knows all the 3 networks as what directly connected as per generic routing is considered. Right? Now what happens is the most important thing to understand. Once this is done, okay? So let's say you have taken a firewall, you have taken 2 interfaces. Say interface number 1, interface number 2, this is going to outside, this is your inside. You have placed the security level as 100 over here, you have placed the security level as 0 over here because of the trust concept, right? And whatever IP, whatever I say 11 and 10, whatever is there, think about it. So now, by default, what happens? That is a default traffic flow. There's a concept of now traffic flow. There are 2 kinds of traffic flow that you can initiate or you can work with your ASA firewalls. One is called as through traffic and one is called as to traffic, right? Through means the traffic that is passing through the firewall, or it is a transit traffic. So say some traffic is passing from your inside network to outside, that means the traffic should traverse the firewall from one port to other port and go outside. That is called as a through traffic. To traffic are generally your management traffic, generally saying. They're your management traffic, right? Which is actually, pointed to the interface of the firewall. So from the inside users, if somebody wants to, telnet this interface or SSH this interface, or, gather some sort of, console access or management access, those are called as a to traffic. So telnet access to the interface or SSH access to the interface might be HTTPS access as well, right? So through traffic is generally the transit traffic. Okay. Now, by default on this firewall interfaces, as a to traffic, what is allowed is only ICMP. So ICMP is allowed by default. So ICMP is allowed by default. Okay. So you will not have any other service, that is allowed apart from ICMP. That means if somebody, some user over here, say 10.11.11.99, if he wants to ping this interface, say this interface IP is 10.11.11.10, from here, if he wants to send ICMP request, he will be getting the ICMP response, because by default, ICMP services are there on the firewall interface. But if this user wants to telnet or SSH this particular IP address, they cannot do that, because telnet, SSH, HTTP, HTTPS, those services are blocked by default, or it is not there by default. Okay, same thing even on the outside port. What happens is ICMP is there on any interface by default on the firewall, so people can ping the interface and check the connectivity with the firewall ports. Okay, so if you want to enable telnet, SSH, HTTP access on the firewall interface, they are generally configured using a property called as service. So you will be configuring not ACL, you'll be configuring something called a service. I will teach you how to configure service in a moment. Hold on for that. We will see that tomorrow, the remote management stuff. But understand today that you configure something called a service on the interface to allow two traffic. And by default, ICMP is the only protocol that is allowed on the interface. Now regarding transit traffic, so traffic that is actually traversing the firewall from one zone to other zone. You can see this names also as zone information. Okay, so let us say we are sending a traffic from inside to outside, that is transiting. So by default, what happens is any traffic which is traversing from high security level to low security level are allowed. So if there is any traffic which is getting initiated from your inside to outside, that is going from high security level to low security level, any traffic is allowed. Pressurize on this word, any traffic. That means what? HTTP, HTTPS, DNS, Telnet, ICMP, whatever you want to send from inside to outside, that is traversing security level high to low, any traffic is allowed to travel through the firewall, provided the routing table entry is there. So if 1011 wants to reach some destination, and regarding destination the firewall don't have a routing entry, the packet will be dropped. But if the routing table entry says yes, I know where is the destination in my routing table, that means I will allow the traffic from the high SQ or high security level to low security level. Not only this, once any traffic is getting allowed, especially the TCP based traffic and the UDP based traffic, they are inspected. And all TCP and UDP traffic, they will have a stateful entry into a table called as a connection table. So if I am sending HTTP traffic, or let us say telnet traffic, right, which is going from inside to outside, it is allowed by default. And what will happen? This traffic will have a connection table entry when the traffic was traversing through. And in the connection table, you will normally keep the return entry of the traffic. You normally keep the return entry of the traffic. So for example, if the source of the traffic was X, it was trying to go to Y. Okay. So in the connection table, what we'll have is you'll have the reflexive entry. So now the firewall knows that okay, X went to Y, so I should allow this traffic because it is going from high to low security level. And also if it is a TCP traffic, I should keep this entry in the connection table. So in the connection table, it will write down what? That I will allow Y to talk back to X, the return entry. Okay, along with the port numbers. So I will show this in practical, it will make much more sense, but theoretically try to understand this very important stuff. So make sure that all traffic is allowed by default from high security to low security. What is allowed by default is TCP UDP based traffic are inspected, but anything else apart from TCP UDP, they will not be into the connection table. So for example, if you are sending now ICMP traffic, right, which is from inside to outside, your ICMP traffic does not fall under the category of TCP UDP, right, because ICMP is a own layer 3 protocol. So those information of ICMP will not go in the connection table. All right. So this is very, very important to understand. Now, Can any traffic come from outside to inside? The answer is no. If there is any traffic which is getting initiated from outside, and if they are trying to traverse the firewall and come inside, by default what happens is the firewall will deny that on the outside port itself. The first big reason is, it is going from a security level which is low to high. So any traffic that is coming from low security level which is going to high security level are blocked by default. Now, if you want to allow some traffic which is getting initiated on the outside and they want to reach inside, for example, you have to write down explicit ACL for that, right? So you can allow this traffic manually by writing what? Explicit access control list statements. And these things will be actually the focus of your study during the ASA courses. But understand this, by default, nothing is allowed to come from outside to DMZ or outside to inside if the traffic is getting initiated from the outside world. But if the traffic is initiated from DMZ to outside or inside to outside, the traffic can go. And also the TCP/UDP based traffic will be inspected, and there will be a connection table maintained for TCP based traffic. All right, we'll talk more and more about it. So as a basic thing, I hope it is clear to everybody. Connection table is created once there is any traffic that is traveling from high security level to low security level. All right. And also one more thing, this concept of security level, it is only there with ASA. It is not there with any other firewall vendors. So keep that in mind.